This is section 6.3, part 1, and we're going to, in section 6.3, determine if I give you a quadrilateral, does it qualify as a parallelogram? Now, in section 6.2, we talked about all the properties and characteristics of parallelograms, okay? So now what we're going to do now is there are certain things that a quadrilateral has that if it has these things, then this is going to be a parallelogram. And you're going to have to decide, is this enough information for me to have a parallelogram? It's very similar to the characteristics and the properties, but it is different as well. Okay, so as I look at this, there's also a different section, I've put some different notes in here as well outside of this first page. So the second page and third page for section 6.3 are not included in here. What I want you to do when you get to that page, second page, is I'll have you write down this information on either a separate page in your notes, or you can find a blank part on page 2 and 3 to write these down. Okay, so let's talk about what is it about a quadrilateral, in a quadrilateral, that will make it a parallelogram. Well, the first thing that we look at is if both pairs of opposite sides, and it has to be both pairs, if both pairs of opposite sides of a quadrilateral are congruent, then it's a parallelogram. But it can't just be one pair, it's got to be both pairs. Okay? Both pairs of opposite sides have to be congruent to each other in order for it to be a parallelogram. That's one thing that we can look at. Okay? Second thing, if an angle of a quadrilateral is supplementary to both of its consecutive angles, okay, then the quadrilateral is a parallelogram. For example, what it's saying here is if I take angle A has to be supplementary to both D and both B in order for it to be a parallelogram. If it's not consecutive to both of those, then it's not a parallelogram, it's just a quadrilateral. Okay? The third one, if both pairs of opposite angles, again, both pairs of opposite angles are congruent, then it's a quadrilateral that is a parallelogram. Okay? But both pairs of opposite angles have to be congruent. Okay. The fourth one, if the diagonals of a quadrilateral bisect each other, then that's a parallelogram. That's exactly the same as a characteristic of a parallelogram. Okay? These other ones have had some different subtleties to them that make them a little bit different. All right? But this one, diagonals have to bisect each other. And then that quadrilateral is a parallelogram. And then the last one is something that's new and different. It says if one pair of opposite sides of the quadrilateral is both congruent and parallel, then the quadrilateral is a parallelogram. Okay? So if opposite sides are both congruent and parallel, then at the same time, then that quadrilateral is a parallelogram. Okay, now let's take a look here at a couple of examples that I'm going to put you through. Again, remember what I said, pages 2 and 3 we're not going to include in here. We're going to go through some different examples on this. So it says, can you prove the quadrilaterals is a parallelogram based on the given information? All right, as you look at the information, you'll notice in problem number 13 that opposite sides here are congruent and opposite sides here are congruent. Okay, so can I determine that this is a parallelogram? I sure can, because opposite sides are congruent, and this is both pairs of opposite sides are congruent. You can't just use one pair. Has to be both pairs. Okay, number 14 in this case. 14, you look at 14, and you'll notice that this, in this case, this diagonal is bisected, but only one diagonal is bisected. It has to have both diagonals bisected, so there has to be two marks here. Again, you can't assume this. So, this is not a parallelogram, because in this case we do not have enough information. That's the reason why it's not. Okay? It did not show that these two sides were also bisected as well. And since it didn't show that, we cannot assume that they are congruent. Therefore, there's not enough information there to prove that that's a parallelogram. Number 15. Okay, number 15, we have opposite angles here are congruent and opposite angles here are congruent. Well, since both opposite pairs of angles are congruent to each other, we can say that is a parallelogram, okay, because opposite angles are congruent to each other, and that means that both opposite angles are congruent to each other. Okay, example number 9 now is going to ask you, what are the values of x and y where you could have this shape A, B, C, D be a parallelogram? Well, as you look at this, you're seeing the angles. So there's a couple ways you could prove this. You could show that the angles consecutive are supplementary. The trouble is you're going to have two variables there, so it's kind of hard to do that. But we also know that both pairs of opposite angles have to be congruent to each other. So I could say that 3y has to equal y plus 78, and 3x has to equal 4x minus 21. And I could solve these. Now, as I look at this first equation, if I subtract y, this ends up being 2y equals 78. And if I divide by 2, in this case, y is going to equal 39. So y has to be 39 in order for this to be a parallelogram. Over here on the right, if I subtract 4x, I end up with negative x equals negative 21. Divide by negative 1, and x is going to equal 21. So in order for this shape, this quadrilateral, to be a parallelogram, x has to be 21 and y has to be 39. Now, these are a couple of examples as to what they're going to be looking at in some practice problems that you have. Again, very similar to what you saw in section 6.2 with a couple of different variations. All right, this concludes section 6.3, part 1. Don't forget to complete your WSQ.